Hello, in this lecture we'll find out the green area using two different methods. In the drawing we have a quarter circle. AOP is a quarter circle, and inside this quarter circle we have quadrilateral AOBC, and our mission is to find out the area of this quadrilateral. In addition, we know that side AC of the quadrilateral is equal to 24 units, side CD equals to 7 units, and this angle ACD equals to 90 degrees. And we have to find out the area of quadrilateral ACDO. We start with the first method. AOB is a quarter circle, therefore this angle equals to 90 degrees. Angle AOB equals to 90 degrees. The point O is the center of the circle that we can create by completing this quarter circle to a circle. In the next step, from point O, that is the center of the circle, we'll draw perpendicular on AC. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AC as P. So from the center of the circle, that is to say from point O, we draw perpendicular on chord AC. Here we have rule number 11. According to rule number 11, the perpendicular to a chord drawn from the center of the circle bisects the chord. Point O is the center of the circle. From point O, we go perpendicular on chord AB. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. So whenever you draw perpendicular to any chord, then the perpendicular OM is not only perpendicular to AB, but it is also bisect chord AB. That is to say, AM equals to MB. We can actually implement this rule number 11 in our drawing. Because in our drawing we have the perpendicular AP to chord AC. According to rule number 11, the perpendicular OP to chord AC is also bisect chord AC. That is to say, AP equals to PC. AC in total is 24. Therefore, each half will be equal to half of 24. 24 over 2. 24 over 2 is 12. So the first half AP will be equal to 12 units. And the second half PC will be also equal to 12 units. In the next step, we will draw another perpendicular from point D on OP. So this angle equals to 90 degrees. And this angle also equals to 90 degrees according to our construction. We will find the touching point of the perpendicular from point D and PO as Q. We get here quadrilateral PC DQ. Inside quadrilateral PC DQ we have 1, 2 ferrite angles. The sum of ferrite angles is 90 times 3 is 270 degrees plus the size of this fourth angle. In total, the sum of those four angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. Again, in order to complete the sum of the angles in quadrilateral PCQD to 360 degrees, the missing angle here must be equal to 90 degrees. So inside quadrilateral QPCD we have 4 right angles. Any quadrilateral that has 4 right angles must be this rectangle if not a square, so we will relate to quadrilateral QPCD, this quadrilateral as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say PC equals to QD. But PC is 12, therefore QD must be also equal to 12. Likewise, in rectangle QPCD, QP must be equal to DC. But DC is 7, therefore QP must be also equal to 7 units. We define the length of line segment QO as X. We focus on the right triangle OQD. We define angle QODQ as alpha. So in this right triangle OQD, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. That is the sum of the angles in any triangle. So this angle equals to 90 degrees minus alpha. We define 90 degrees minus alpha as beta. Therefore, this angle will be equal to beta. We know that angle AOB, this angle equals to, in total, to 90 degrees. So 90 degrees, that is angle AOB minus angle beta, will be equal to angle AOP. Again, 90 degrees, that is angle AOB minus beta, will be equal to the missing angle, angle AOP. So I write it down, 90 degrees, that is the side of this angle, angle AOB minus beta, must be equal to the missing angle, that's angle AOP. Angle AOP. So it is 90 degrees minus beta, and beta is 90 degrees minus alpha. So you can write here that we can substitute beta by 90 degrees minus alpha. And this expression in total will be equal to 90 degrees minus 90 degrees is 0. Minus times minus is plus. So in total this expression equals to alpha. So angle AOD, that is the missing angle, equals to alpha. This is the missing angle, angle AOP. Angle AOP equals to alpha. So in the right triangle APO, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta. Therefore, angle OAP equals to beta. We focus on the right triangle OQD. So I copy the right triangle OQD in a new page, and I find out the value of tangents alpha here. So I copy the right triangle OQD. So this is the right triangle OQD that I copied from the original drawing. QO equals to x according to our definition, QD equals to 12 units. So in this right triangle of QD, tangent alpha equals to OQ over QD. OQ equals to x and QD equals to 12. So you can say that the tangent alpha in the triangle OQD equals to x over 12. This is equation number 1. We focus on the right triangle APO. So I'll copy the right triangle APO in a new page and we'll find out the value of tangent alpha in this right triangle APO. AP equals to 12 units. What is the value of PO? From the drawing it is easy to see that PO equals to PQ plus QO. That is to say PO equals to PQ, that is 7, plus QO, that is x. So in total PO equals to x plus 7. So finally, this is the right triangle APO that I copied from the original drawing. Tangent alpha in this right triangle APO equals to AP over PO. AP is 12 and PO is x over x plus 7. So in total we found out that according to equation number 2, tangent alpha equals to 12 over x plus 7. So we have two different expressions for tangent alpha. Tangent alpha according to equation number 1 equals to x over 12. And tangent alpha according to this equation number 2 equals to 12 over x plus 7. In the next step we'll create equation number 3 that states the tangent alpha according to equation number 1 must be equal to tangent alpha according to equation number 2. So tangent alpha according to equation number 1 equals to x over 12, and it must be equal to tangent alpha according to equation number 2, that is equal, actually according to equation number 2, tangent alpha equals to 12 over x plus 7. So found out that according to equation number 3, x over 12 equals to 12 over x plus 7. We of course multiply this equation and equation number 3, and we get that according to equation number 3, x times x plus 7 equals to 12 times 12, that is 144. We'll open the brackets on this side of equation number 3, and we get that according to equation number 3, x times x is x squared plus x times 7 is 7x. this is equal to 144. We'll subtract 144 from this equation, and finally we get the quadratic equation that x squared plus 7x minus 144 equals to 0. This is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, of this quadratic equation, the general quadratic equation, and x is the variable that we are looking for. In our specific quadratic equation, here the coefficient a equals to 1, the coefficient b equals to 7, and finally the coefficient c equals to minus 144. And we can find out the value of x by using the following formula, that x will be equal to minus b plus minus square root of b squared minus 4 times a times c over 2a. Here a, b, and c are the coefficients of the quadratic equation. Now we'll put the values of a, b, and c in this quadratic equation, in this the solution to the quadratic equation, in order to find out the value of the values of x. I'll remind you that according to our definition, the length of line segment QO equals to x. So we have to find out the length of line segment QO, that is x. So x equals to minus b. B is 7, therefore minus b is minus 7, plus minus the square root of b squared. B is 7, so b squared is 7 squared, that is 49, minus 4 times a is 1, times c is minus 144, c is minus 144, over 2a. A is 1, so 2a is 2 times 1, that is 2. So I found out that x equals to minus 7 plus minus 4 times 144, again minus 4 times minus 144 is plus 576 plus 49. In total it is equal to 625. So inside the root we left with only 625 over 2. So here we have x equals to minus 7 plus minus, and the square root of 625 is 25 over 2. Repeat again, and confirm we found out that x equals to minus 7 plus minus 25 over 2. So here we will have two solutions that are possible for x. The first solution for x is x equals to minus 7 minus 25 over 2. Minus 7 minus 25 is minus 32 over 2. So minus 32 over 2 is minus 16. So we found out that according to the first solution, x equals to minus 16. But because of the fact that x is the length, and the length must be a positive number, we cancel this solution. It is impossible that x will be equal to a negative number, and we left only with the second solution that is possible for x. The second solution for x is x equals to minus 7 plus 25 over 2. 25 minus 7 is 18, and 18 over 2 is 9. So if we're going to find out, according to the second solution, x equals to 9. So here, the value of this line segment QO equals to x equals to 9. So here we have to find out the green area, that is the area of quadrilateral AODC. Quadrilateral AODC, we divide the area of quadrilateral AODC to 3 parts. The first part will be the area of the right triangle APO, that we will define as A1. The second part of the area of the green shape will be the area of the right triangle OQD, that we define as A2. And finally, the third part is the area of rectangle QPCD, that we will define as A3. It is obvious that the area of the green shape equals to A1 plus A2 plus A3. So we calculate each area separately. So I write it down, the area of the green shape equals to A1 plus A2 plus A3. And again, we have to find out the area of the green shape that is equal to A1 plus A2 plus A3. So what is the area of A1? The area of A1 is the area of the right triangle APO. So we copy the right triangle APO on your page, and we find out the area of the right triangle APO. AP equals to 12 units. Again, we have already found out that PO equals to x plus 7. X is 9, so 9 plus 7 is 16. So PO in total equals to 16 units in its length. So this is the right triangle APO that I copied from the original drawing. The area of this right triangle will be equal to the base of the triangle, that is AP, times the height to the base, that is PO, over 2. AP is 12, times PO is 16, over 2. 16 over 2 is 8, so in total this expression equals to 12 times 8. 12 times 8 is 96. So in conclusion, found out that the area of A1, that is the area of the right triangle APO, equals in total to 96 square units. In the next step, we find out the area of A2, that is actually the area of the right triangle OQD. So I'll copy the right triangle OQD in a new page, and we find out the area of this right triangle. OQ equals to x and x equals to 9, so QO equals to 9 units is x, and QD equals to 12 units. So this is the right triangle OQD that they copied from the original drawing. This is the area of A2. The area of this right triangle OQD equals to the base of the triangle, that is QO, times the height of the base, that is QD, over 2. QO equals to 9, QD equals to 12, divided by 2. 12 over 2 is 6, and 6 times 9 is 54. So we can find out that A2 equals to 54 square units. And finally, we have to find out the area of A3, that is actually the area of rectangle QPCD. The area of any rectangle is the length of the rectangle times the width. The length is PC, times the width, that is PQ. So the area of rectangle PQCD equals to PC times PQ. PC is 12 and PQ is 7. And 12 times 7 is 84. So in total A3 equals to 84 square units. Repeat again that the area of the green shape equals to A1 plus A2 plus A3. Write it down again. The area of the green shape equals to A1 plus A2 plus A3. A1 equals to 96 square units plus A2 that is equals to 54 square units plus A3 that is equal to 84 square units. So 96 plus 54 is 150, and 150 plus 84 is 234. So in conclusion, found out that the area of the green shape equals in total to 234 square units. Repeat again. The area of this green shape equals to 234 square units. So we finished with the first method. In the next step, I present to you how to find out the area of this green shape according to the second method. In the second method, we join points A and D together by a straight line. By joining points A and D, we created the right triangle ACD. We calculate the value of the length of the hypotenuse AD in the right triangle ACD. So I copy the right triangle ACD, new page, and find out the length of the hypotenuse AD. CD equals to 7 units in its length, and AC equals to 24 units in its length. So actually, this is the right triangle ACD, the point from the original drawing. CD equals to 7 and AC equals to 24. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say AD square equals to AC square plus CD square. So AD square equals to AC square. AC is 24, therefore AC square is 24 squared, that is 576, plus CD square. CD is 7, therefore CD square is 7 squared, that is 49. So in conclusion, found out that AD square equals to 576 plus 49, it is 625. We will take a root out of this equation and we get that AD equals to the square root of 625, this is actually 25. We found out that the hypotenuse AD here equals to 25 units. This angle equals to 90 degrees because of the fact that AOB is a quarter circle and point O is always the center of the circle that we can create by completing this quarter circle to a circle. So we'll actually complete the quarter circle to a circle. We completed the quarter circle to a circle. Point O is the center of this circle, point A is the point of the circle itself. Therefore OA is the radius of this circle. We define the radius of this circle as R, so OA equals to R. We will extend the radius OA by a straight line until it touches the circle. We define the touching point of the extended radius AO and the circle as M. Point O is the center of the circle, point M is the point of the circle itself, therefore OM is the radius of the circle, that is equals to R. So we have chord AM that passes for the center of the circle. That is to say, it passes for point O, that is the center of the circle, and any chord that passes for the center of the circle must be the diameter of this circle, and therefore AM is the diameter of the circle. AM is the diameter of the circle. Is equals to R plus R, that is 2R. Indeed, the diameter of a circle equals to 2 times the radius. So if I know that AM is the diameter of this circle, in the next step we will extend side CD by a straight line until it touches the circle. And the question is where the extended side CD will touch the circle. We will assume that the extended side CD will touch the circle not at point M but in any other point, like for example it will touch the circle at this point that we will define as point N. So we have angle ACN that is equal to 90 degrees and it rests on chord AN. But it will contradict rule number 5. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Here we have peripheral angle MAN that is equal to 90 degrees, and this peripheral angle MAN rests on chord MN that is the diameter of this circle. And here peripheral angle ACN is peripheral angle that is equal to 90 degrees. Therefore it must rest on AM, that is the diameter of the circle, but according to our assumption it doesn't rest on AM but it rests on chord AN. Peripheral angle ACN rests on chord AN, that is not the diameter of the circle. It contradicts rule number 5 that we have peripheral angle ACD, the extended ACD must rest on the diameter of the circle, that is to say on AM. Okay, so because of the contradiction that we got here, we must conclude that the extended CD must touch the circle at point M and not in any other point. So here you tell that the extended CD, the extended side CD touch the circle at point M, and then we will have peripheral angle ACM is equal to 90 degrees, and indeed this peripheral angle ACM that is equal to 90 degrees, it indeed rests on AM, that is the diameter of the circle, exactly according to rule number 5. So in order to avoid the contradiction to rule number 5, we conclude that the extended CD must touch the circle at point M and not in any other point. Okay. So AM is the diameter of the circle, therefore it is absolutely a straight line. If you focus on this side of the straight line AM at point O, here the sum of the angles must be equal to 180 degrees. So which angles we have? At this side of AM at point O, we have this angle that is equal to 90 degrees plus the missing angle. In total must be equal to 180 degrees according to the rule that I mentioned, that the sum of the angles from one side of a straight line is equal to 180 degrees. Therefore the missing angle here must be equal to 90 degrees. Again, in order to complete the sum of the angles on this side of AM at point O to 180 degrees, the missing angle here must be equal to 90 degrees. In the next step we will prove that the right triangle AOD is congruent to the right triangle DOM. So I write it down. The right triangle ADO, the right triangle ADO is congruent to the right triangle DOM. So why those two right angles can go into each other? First of all, AO equals to OM equals to R. They are both the radius this circle, therefore they are equal to each other. So AO equals to OM equals to R. They are both the radius of the circle, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. So angle AOD equals to this angle MOD again, angle AOD equals to angle MOD, they are both equal to 90 degrees, therefore they are equal to each other. And finally, side OD is the common side that belongs to both triangles, so OD equals to itself. OD equals to itself, it's a common side that belongs to both triangles. Repeat again. OD equals to itself is a common side that belongs to both triangles. So we actually proved that the right triangle ADO is congruent. This is the sign of congruent to the right triangle DOM according to side angle side rule. Those two sides and the angle between them are corresponding equal to those two sides and the angle between them in both triangles. So those two triangles can go into each other according to side angle side rule. And from the fact that they can go into each other, we will derive that side AD equals to side DM. AD equals to DM. AD equals to DM according to the rule that corresponding sides of congruent triangles are equal to each other. Those two triangles can go into each other, therefore the two corresponding sides AD and DM must be equal to each other. But AD equals to 25. We already found out that AD equals to 25, so we can write here that AD equals to 25. And from this equation 25 equals to AD equals to DM, we will derive that DM is also equals to 25. So here, this side DM equals to 25 units in its length. So what is the length of side CM? First of all, CM is one straight line because we extended the side CD by straight line and we got this CM. When we extend the straight line by straight line, the result must be a straight line, so CM is one straight line. So and therefore CM in total it is equals to CD plus DM. CD is 7 and DM is 25, so 25 plus 7 is 32. So CM equals to 32, AC equals to 24, and AM is the diameter of the circle that is equal to 2R. So I copy the right triangle ACM, and in equation we implement in this right triangle ACM the Pythagoras theorem. CM equals to 32 units in its length, and AM is the hypotenuse, it is equals to 2R. So actually, this is the right triangle ACM that I copied from the original drawing. By PT is the equation for Pythagoras theorem, and this right triangle ACM, according to the Pythagoras theorem, we get that AM squared, that is the square of the hypotenuse, equals to AC squared plus CM squared. AM is 2R, therefore AM squared is 2R squared, that is 4R squared. That is equal to AC squared. AC is 24, therefore AC squared 24 squared, that is 576 plus CM squared. CM is 32, therefore CM squared is 32 squared, that is 1024. So found out that 4R squared equals to 1024 plus 576 in total equals to 1600. So we found out that 4R squared equals to 1600. We divide this equation by 4 and we get that R squared equals to 1600 over 4 is 400. R squared equals to 400. We take a root out of this equation and we get that R equals to the square root of 400. That is actually 20. So we found out that the hypotenuse that R, the radius of the circle, equals to 20 units. Here, AO is the radius of this circle. R equals to 20 units. In the next step, we'll implement the Pythagoras theorem on the right triangle AOD in order to find out the value of OD. So copy the right triangle AOD in a new page and we'll implement the Pythagoras theorem on this right triangle AOD. AD equals to 25, it's actually the hypotenuse of the right triangle AOD. AO is the radius of the circle, that is equal to 20 units. So actually, this is the right triangle AOD that I copied from the original drawing. According to the Pythagoras theorem, and this right triangle AOD, AD squared equals to AO squared plus OD squared, that is the missing side. AD is 25, therefore AD squared is 25 squared, that is 625. And it is equal to AO squared. AO is 20, therefore AO squared is 20 squared, that is 400, plus OD squared. So we found out that 625 equals to 400 plus OD squared. We subtract 400 from this equation, and we get that OD squared equals to 625 minus 400 is 225. We take a root of this equation and we get that OD equals to the square root of 225. It is actually 15. Here OD equals to 15 units. OD equals to 15 units in its length. Our mission is to find out the area of this green shape. We divide the area of the green shape into two parts. The first part will be the area of the right triangle AOD, that will be A1, plus the area of the right triangle ACD will be A2. And it is obvious that A1 plus A2 in total will be exactly the area of the green shape. Okay, so I'll write it down, that the area of the green shape in total will be equal to A1 plus A2. A1 is the area of the right triangle AOD. OD equals to 15, AO equals to 20. So what is the area of this right triangle? Is equals to the base, that is OD, times the height to the base, that is AO, over 2. OD is 15 times AO, that is 20, over 2. 15 times 20 is 300, 300 over 2 is 150. So in conclusion, found out that A1 equals to 150 square units. A2 is the area of the right triangle ACD, so I copy the right triangle ACD. CD equals to 7 and AC equals to 24. Again, A2 equals to the area of the right triangle ACD. This is the right triangle ACD that I copied from the original drawing. The area of this right triangle will be equal to the base, that is CD, times the height to the base, that is AC, over 2. CD equals to 7, AC equals to 24 over 2. 24 over 2 is 12. So in total, this expression equals to 12 times 7, that is 84. In conclusion, found out that A2 equals to 84. Then the area of the green shape is equals to A1 plus A2. We have already found out that A1 equals to 150 square units, plus A2, that is 84 square units. 150 plus 84 is 234 square units. In conclusion, we found out that the area of the green shape equals to 234 square units. Okay, in the next step, I will summarize the lecture. We start with the first method. In this lecture, we found out the area of this green shape. In the drawing, we have a quarter circle. AOB is a quarter circle. Inside this quarter circle, we have quadrilateral AODC, and our mission is to find out the area of this quadrilateral, the green quadrilateral AODC. In addition, we know that side CD of quadrilateral AODC equals to 7 units in its length, side AC equals to 24 units in its length, and this angle ACD equals to 90 degrees. Again, our mission is to find out the area of the green quadrilateral ACOD. First of all, because of the fact that AOB is a quarter circle, this angle AOB must be equal to 90 degrees, and point O is also always the center of the circle that we can create by completing this quarter circle to a circle. Okay, so first of all, we did a construction. We actually, from point O, that is the center of the circle, we draw perpendicular on chord AC. Again, from point O, we draw perpendicular on chord AC. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AC as P. And then I presented to you rule number 11. According to rule number 11, the perpendicular to a chord drawn from the center of a circle bisect the chord. Point O is the center of the circle. From point O, we draw perpendicular on AB. That is to say, this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. And whenever we have a perpendicular that is drawn from the center of the circle, that is to say, from point O, that is perpendicular to chord AB. Again, OM is perpendicular to AB. Then OM will be also bisect chord AB. That is to say, AM will be equal to MB. So whenever we go perpendicular from the center of the circle towards any chord, it will also bisect the chord. In this case, because of the fact that OM is perpendicular to AB, then OM will also bisect AB. That is to say, AM equals to MB. You can actually implement rule number 11 in our drawing, because in our drawing we have from the center of the circle, that is to say from point O, we draw perpendicular on chord AC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. And according to rule number 11, the perpendicular OP also bisects chord AC. That is to say, OP divides chord AC into two halves. The first half is AP and the second half is PC. And because of the fact that in total AC equals to 24 units, each half will be equal to 24 over 2. So this the first half AP equals to 24 over 2, this is 12, and the second half PC will be also equal to 12 units in its length. In the next step, this is the implementation of rule number 11 in our drawing. From point D, we draw perpendicular on PO. Again, from point D, we draw perpendicular on PO. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. So we actually created here quadrilateral PCQD. We define the touching point of the perpendicular from point D and PO as Q. So we have here quadrilateral PCQD. Inside quadrilateral PCQD, we have 1, 2, 3 right angles. This angle equals to 90 degrees according to what is given as the equation. The sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of this fourth angle. In total, the sum of the angles in this quadrilateral PCQD must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this missing angle must be equal to 90 degrees. Okay. So we found out that inside quadrilateral PCQD we have actually 4 right angles. Therefore, we relate to quadrilateral PCQD as a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, CD equals to PQ. But CD is 7, therefore PQ must be also equal to 7. Likewise, in rectangle PCQD, PC must be equal to the opposite side, QD. But PC is 12, therefore QD must be also equal to 12 units. Then we define the length of this line segment QD as X. We focus on the right triangle OQD. We define angle QDO as alpha. So in the right triangle QOD, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles in any triangle. So this angle equals to 90 degrees minus alpha. We define 90 degrees minus alpha as beta, therefore this angle is beta. we know that angle AOB equals to 90 degrees. This angle AOB equals to 90 degrees. This angle equals to beta, therefore 90 degrees minus beta must be equal to the missing angle, angle AOP. So angle AOP equals to 90 degrees minus beta. But beta is 90 degrees minus alpha, so you can substitute beta here by 90 degrees minus alpha. So if we open the brackets, we get that 90 degrees minus 90 degrees is 0, and minus times minus is plus. So in total, this expression equals to alpha. So we found out that the missing angle, angle AOP here, this missing angle equals to alpha. So in the right triangle POA, this angle equals to alpha. This angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha is beta, so we can write here that this angle equals to beta. Then we focus on this right triangle, OQD. OQD. So copy the right triangle OQD in a new page, and we found out the value of tangent alpha in this right triangle OQD. This is the right triangle OQD. This is coming from the original drawing. QD equals to x according to definition. QD equals to 12. QO equals to x according to definition. And this is angle alpha. So in this right triangle QD, we'll get the tangent alpha equals to QD QO over QD. Again, tangent alpha equals to QO over QD. Tangent alpha equals to QO over QD. QO is x and QD is 12. Okay? So in total, we found out that tangent alpha equals to x over 12. Tangent alpha equals to x over 12. Then we focused on the right triangle APO. I copy the right triangle here. This is the right triangle APO that I copied from the original drawing. AP equals to 12. What is the length of PO? PO equals to PQ plus QD. That is to say, PO equals to PQ, that is 7, plus QO, that is x. So in total, PO equals to x plus 7. Okay. Here, PO equals to x plus 7, AP equals to 12, and this is angle alpha. So in this right triangle APO, tangent alpha equals to AP over PO. Tangent alpha equals to AP over PO. AP is 12, PO is x plus 7, so in total we found out that actually tangent alpha equals to 12 over x plus 7. So we have two different expressions for tangent alpha. In the next step, we created equation number 3 that states that tangent alpha according to equation number 1 must be equal to tangent alpha according to equation number 2. Repeat again. We created equation number 3 that states that tangent alpha according to equation number 1 must be equal to tangent alpha according to equation number 2. Tangent alpha according to equation number 1 equals to x over 12, and must be equal to tangent alpha according to equation number 2, that is equals to 12 over x plus 7. So in conclusion, we found out that according to equation number 3, x over 12 equals to 12 over x plus 7, because multiply this equation, and found out that x times x plus 7 equals to 12 times 12, that is 144. We open the brackets here and found out that x times x is x squared, and x times 7 is 7x. It is equal to 144. We subtracted 144 from this equation and found out finally that x squared plus 7x minus 144 equals to 0. This is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. In our specific quadratic equation, x squared plus 7x minus 144, the coefficient a equals to 1, the coefficient b equals to 7, and the coefficient c equals to minus 144. So this is the general formula for a quadratic equation. A, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. We will find out the value of x according to this special formula. X equals to minus b plus minus square root of b squared minus 4 times ac over 2a. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. So we'll put the data inside this equation in order to find out the value of x. I want to you that x equals to the length of line segment QO. So x equals to minus b is 7, so therefore minus b is minus 7, plus minus the square root of b squared, b is 7, so therefore b squared is 7 squared, that is 49, minus 4 times a is 1, and c is minus 144, over 2a is 2. Minus 4 times minus 144 is 576, plus 49, in total it is equal to 625. So inside the root we left only with 625 over 2. The square root of 625 is 25. So this expression in total will be equal to 17 plus minus 25 over 2. Repeat again. And we found out that x equals to minus 7 plus minus 25 over 2. So here we will have two solutions that are possible for x. The first solution is that x equals to minus 7 minus 25 over 2. Minus 7 minus 25 is minus 32, and minus 32 over 2 is minus 16. So the first solution for x is x equals to minus 16. But because of the fact that x is the length of line segment QO, as a length, x must be a positive number, therefore we cancel the solution that x equals to minus 16, and we left only with the second solution that is possible for x, that x equals to minus 7 plus 25 over 2. 25 minus 7 is 18, and 18 over 2 is 9. So in conclusion, we found out that in total x equals to 9. In conclusion, x equals to 9 units in its length. That is to say, the length of this line segment QO, that is x, equals to 9 units. And what is, we are looking for the area of the green shape. We divided the area of this green shape into 3 parts, and we calculated each part, and it is obvious that the area of the green shape equals to A1, that is the area of the right triangle APO, plus A2, that is the area of the right triangle OQD, plus the area of rectangle PCQD, that is A3. So in total, the area of the green shape equals to A1 plus A2 plus A3. I repeat again, the area of the green shape in total equals to A1 plus A2 plus A3. A1 is the area of this right triangle APO, so I copy this right triangle from this original page. AP equals to 12, PO equals to 7 plus x, x is 9, so 7 plus 9 is 16, so PO in total equals to 16. So the area of this right triangle APO equals to AP times PO over 2. AP is 12, PO is 16 over 2. 16 over 2 is 8, so in total this expression equals to 8 times 12. 8 times 12 is 96. So in conclusion, found out that the area of this right triangle APO equals to 96 square units. Then we found out the area of A2. The area of A2 is the area of this right triangle OQD. So put the right triangle OQD in here. QD equals to 12, and QO equals to 9. So the area of this right triangle QOD equals to QD times QO over 2. QO is 9 and QD is 12 over 2. 12 over 2 is 6, so in total this expression equals to 9 times 6, that is 54. So we found out that A2 equals to 54 square units plus A3. A3 is the area of this rectangle PQCD. The area of a rectangle is the width times the length. The width, the length is PC, and the width is PQ. Actually, the length is PC and the width is PQ. PC equals to 12 and PQ equals to 7, so in total the area of rectangle PQCD equals to 7 times 12, that is 84. 84 square units. So we found out that in total the area of the green shape equals to A1 plus A2 plus A3. A1 equals to 96 square units, A2 equals to 54 square units, and finally A3 equals to 84 square units. 96 plus 54 is 150, and 150 plus 84 is 234. So in conclusion, found out that the area of the green shape, the area of this green shape equals to 234 square units. We finished with the first method, then I presented to you how to find out the area of this green shape according to the second method. In the second method, we joined points A and D together by a straight line. In this way, we created the right triangle ACD. So copy the right triangle ACD here, and we implemented the Pythagoras theorem on this right triangle ACD. AC equals to 12, CD equals to 7. So according to the Pythagoras theorem, AD square equals to AC square plus CD square in the right triangle ACD. AD square equals to AC square. AC is 24, therefore AC square is 24 squared, that is 576 plus CD square. CD is 7, therefore CD square is 7 squared, that is 49. So in conclusion, found out that AD square equals to 576 plus 49, that is actually 625. AD square equals to 625. We took out of this equation and found out that AD equals to the square root of 625, that is 25. So we found out that the hypotenuse AD equals to 25 units in its length. Then we did the construction. We completed this quarter circle to a circle. Point O is the center of this circle. Point A is the point of the circle itself. Therefore, OA is the radius of this circle. We define the radius of this circle as R. So AO equals to R. Then we extended the radius AO until it touches the circle at point M. Point O is the center of the circle. Point M is the point of the circle itself. Therefore, OM is the radius of this circle, that is equal to R according to our definition. AM is a chord that passes through point O, that is the center of the circle. Any chord that passes through the center of the circle must be the diameter of the circle. Therefore, AM is the diameter of the circle, and indeed AM equals to R plus R, that is to R, and to R is twice as long as the radius, exactly as we expect from the diameter of this circle. AM equals to 2R. Then we extended side CD until it touches the circle at point M. We assumed that the extended side CD will not touch the circle at point M, but at point N. And then we arrive to a conclusion. If the extended side D will touch the circle at point C, then we get that the peripheral angle ACN, that is equal to 90 degrees, rests on chord AN, and chord AN is not the diameter of the circle. And according to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. That is to say, it must rest on AM, that is the diameter of the circle. But if ACN if the extended CD touches the circle at point N, then peripheral angle ACN rests on AN, that is not the diameter. In contradiction to the rule that any peripheral angle that is equal to 90 degrees must rest on AM, that is the diameter of the circle. In order to avoid the contradiction, we will conclude that the extended side CD must touch the circle at point M and not in any other point, and then we get that the peripheral angle ACM that is equal to 90 degrees indeed rests on AM, that is the diameter of the circle, exactly according to rule number 5. Therefore, here, when we extended CD, it must touch the circle at point M and not to any other point. So CDM is one straight line. Then we have, if we focus on this side of the diameter IM at point O, the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have in this side of AM at point O? We have this angle that is 90 degrees. Therefore the missing angle must be also equal to 90 degrees according to the rule that I mentioned. Then we proved that the right triangle AOD is congruent to the right triangle ODM. Why those two right triangles congruent to each other? First of all, AO equals to OM equals to R. AO equals to OM equals to R. They are both the area of the circle, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. Angle AOD equals to angle MOD equals to 90 degrees. And finally, DO is a common side that belongs to both triangles, so DO equals to itself. So we found out that the right triangle AOD can go into the right triangle DOM according to side angle side rule. And from the fact that those two right triangles can go into each other, we will derive that AC equals to CM. Repeat again. AC equals to, again, it's actually AD equals to DM. Again, AD equals to DM. Repeat again. AD equals to DM. AD equals to DM. But here, AD equals to 25. AD equals to 25, and from this equation 25 equals to AD equals to DM, we derive that DM is also equals to 25. This side DM equals to 25 units in itself. So in total, CM equals to CD plus DM. That is to say, CM equals to CD, that is 7, plus DM, that is 25. 25 plus 7 is 32. So CM in total equals to 32 units in itself. AC equals to 24, and AM equals to R, is the diameter of the circle. So I copy the right triangle ACM in a new page, we implemented in this right triangle ACM the Pythagoras theorem. AC equals to 24, CM equals to 32, and AM is the diameter of the circle that is equal to 2R. According to Pythagoras theorem in this right triangle ACM, AM square equals to AC square plus CM square. Again, AM square equals to AC square plus CM square. So AM square equals to AC square. AC is 24, therefore AC square is 24 squared, that is 576, plus CM square. CM is 32, therefore CM square is 32 squared, that is 1024. So in conclusion, found out that 4R square equals to 576 plus 1024. 576 plus 1024 in total equals to 1600. So 4R square equals to 1600. We divided this equation by 4 and found out that R square equals to 1600 over 4 is 400. So R square equals to 400. We took out of this equation and found out that R equals to the square root of 400, that is 20. Here, R equals to 20. Then we implemented the Pythagoras theorem on the right triangle AOD. So I call it the right triangle AOD in a new page, and we implemented here the Pythagoras theorem. This is the right triangle AOD that I copied from the original drawing. AO is the radius, that is 20. We already found out that AD equals to 25. So in this right triangle AOD, we get that AD square equals to AO square plus OD square. AD is 25, therefore AD square is 25 squared, that is 625. And it is equals to AO square. AO is 20, therefore AO square is 20 squared, that is 400, plus OD square. So found out finally that 625 equals to 400 plus the whole square. We subtracted 400 from this equation and finally found out that OD square equals to 625 minus 400 is 225. So OD square equals to 225. We took out from this equation and found out that OD equals to the square root of 225, that is 15. So here OD equals to 15 units in its length. And what is the area of the green shape? The area of the green shape equals to the area of the right triangle AOD, that is A1, plus the area of triangle the right triangle ACD, that is A2. So in total, the area of the green shape equals to A1 plus A2. Repeat again, the area of the green shape equals to A1 plus A2. A1 is the area of the right triangle AOD. So I call it the right triangle AOD here, and calculate the area of this right triangle AOD. AO equals to 20, OD equals to 15. So in total, the area of this right triangle AOD equals to AO times OD over 2. AO is 20, OD is 15 over 2. So it is 15 times 20 over 2. 15 times 20 is 300, and 300 over 2 is 150. So the area of this right triangle AOD equals to 150 units, 150 square units. This is A1 plus A2. A2 is the area of this right triangle ACD. So copy the right triangle ACD here. AC equals to 24 and CD equals to 7. So the area of the right triangle ACD equals to AC times CD over 2. AC is 24, CD is 7 over 2. So it is 7 times 24 over 2. 24 over 2 is 12. So in total this expression equals to 12 times 7, that is 84 square units. So in total we found out that A2 equals to 84 square units. And the area, again, the area of the green shape equals to A1 plus A2. A1 equals to 150 square units plus A2, that is 84 square units. 150 plus 84 equals to 234 square units. So in total, in conclusion, we found out that the area of this green shape, according to the second method, it is also equals to 234 square units. Okay, thank you very much.